Hey guys, how are you doing? Today in this video, we're going to solve maximum sum BST in binary tree problem. This is one of the hard problem on LeetCode. So let's see how do we solve using depth first search recursive method. So let's jump into the problem statement. We're given a binary tree. So the task is to return the maximum sum of all the keys of any subtree, which is also a binary search tree. So any subtree in the given binary tree could be a binary search tree. So we need to add all the node values and return the maximum among such sums. So let's see how do we solve this problem. We'll resize here. So let's create a return type. Max sum so far equals to 0 and return the same. Let's design a recursive function. So I'm going to have a tuple that contains several useful information. We'll see in a moment. So let's say recur, which accepts a tree node. Okay. So let's have a base cases here. So if node equals null, then return some information. So for example, what all the necessary information that we need to return to the caller? Uh, we'll say whether this subtree, given node, has a subtree, right? Whether that subtree is a binary search tree or not, and its minimum value. So in that subtree, what is the minimum value ever occurred? So among all the nodes, we need to find its minimum, and we need to find its maximum, and also we need to find the sum of all the node values. So we're going to return all these information for one particular node given. Okay, so if that node is null, so we say yes, that is a BST, and the minimum value is, we'll stick with integers min value and integers max value and 0 as the sum because it is null, right? So in case it is a leaf node, which means left and right children both are null. Okay, in that case, we need to return uh, this is a BST, right? So any node, any single node is a BST. So that's the status of that. We're going to return that's a BST, and the minimum and maximum value is the same, right? Whatever the node's value is. So let's say node dot val is minimum, node dot val is max, and node dot val is the sum. Okay, so and also we should it's very important that we should update the max. Okay, max so far equals to math dot max sum so far no dot val, because this could exceed the value, right? All right. So these are the base cases which we'll be handling, and we need to recur for we need to know the status of left and right child here. So let's say where left is BST, right, and uh, left min, left max, and left sum. Okay, so we need all this information from record left child. We will be having that status by recurring node dot left. So in case the node is null, so we need to have a constant state information. Let's see if node dot left is null, then we can just say, that's a BST because nothing is there. It's a BST. And left's minimum is nothing but node's value. We'll stick with that. And what is the left max? Okay, what is the left max? Left max, left subtree's maximum value should not exceed the current node's value, right? So we can stick with node dot val minus 1. That's the maximum that can occur for an empty subtree. So, and the sum is 0. All right, this is the constant state that we're going to have when node's left child is null. So which is the state, else we can just recur and get the appropriate result. The same case for right child, right minimum, right max, and right sum. Okay, so node dot write, if it is null, then return that is a BST. And what is the maximum, sorry, what is the minimum value that could, so whatever the node's value should be lesser than the maximum, what overall maximum of right subtree. That's the BST property, right? So minimum should be greater than node's current value. So let's say minimum is node.val plus 1, and we stick with node.value, and sum is 0. Okay, this is just a fallback mechanism to adhere for the properties of binary search tree. That's the reason. So we can recur. If it is not null, node.write. Right? So we have the status of left subtree and the right subtree and appropriate, min, max, and sum, everything. So now what we are going to do is we need to check whether the current node is a BST. Based on these values, we need to derive out whether the current node is the binary search tree or not. So let's say this is BST equals to. So in order to decide whether the current node is a binary search tree, so its left subtree must be binary search tree, and right subtree must be a binary search tree, and also whatever the whatever the max from left must be less than node's current value, right? So then also right's minimum value should be greater than node's value, right? Right. If this tree is a binary search tree, then update. So we need to add the sum, right? So what is the overall sum we got? So we need to add the left subtree sum plus right subtree sum plus the current node's value. Then return the appropriate result. So this is BST. And what is the minimum? So what is the minimum for the current node? The minimum could be, minimum among left min and node dot value, right? So we are going to return the minimum value. So whatever we got minimum in this subtree, because these two are going to be one binary search tree, right? So we need to represent the minimum by comparing the current node's value to the left minimum and max, right? Right's maximum and node's value. And what is the sum? Left sum plus right sum plus node dot. Right? These are the values for the representing a state of the current tree, right? We can invoke this for the root and return the maximum sum so far, right? So let's test this. Okay, somewhere I missed some semicolon. Yeah, okay. Let's try again. Okay, it works. Yeah. Let's try to submit this and check. Right, works. I hope you enjoyed this video and thanks for watching.